In this lesson, we will look at two useful statistical concepts. Part 1, correlation. And Part 2, simple linear regression. There are many different types of correlation coefficients, but the one we will use in this course is the Pearson product moment correlation, which we will call R. Basically, a correlation is a number between -1 and +1 that summarizes the relationship between two variables. The correlation also tells us the magnitude of the relationship between two variables. As the correlation approaches closer to +1, we say that the relationship is strong and positive. Suppose that you have been hired by the owner of a supermarket chain to make a recommendation as to how many shelf facings of Kellogg's Corn Flakes this chain should use. A shelf facing is the number of boxes of the cereal that are stacked beside one another. You track the weekly sales, in thousands of ringgits, of this cereal over a 10-week period, in a supermarket, and the resulting sales figures are given in the table here. We want to determine if there is a relationship between the number of facings of Kellogg's Corn Flakes and the weekly sales of this cereal, and we decide to use a correlation to determine this relationship. Let's call the number of facings, X, and the sales figures, Y. Create an Excel spreadsheet with the following information. Now, complete the remaining figures in the table given. You should be able to obtain the formula for the sample size, mean and standard deviation. Now, we need to find the correlation between the number of facings and the weekly sales dollars. The function is here, in cell B18. Let's compute the correlation value. Since we know that the correlation between the number of facings and sales is +83, this tells us that it makes sense to use the number of facings to predict the weekly sales. We now need to find the regression equation, that is the equation of the best fitting straight line through the data points. To find the regression equation summarizing the relationship between X and Y, we need to check to see if your version of Excel contains the data analysis tool pack necessary to run a regression analysis. Installing the data analysis tool pack. Open Excel spreadsheet. Click on Data at the top of your screen. Look at the top of your monitor screen. Do you see the words Data Analysis at the far right of the screen? If you do, the Data Analysis tool pack for Excel was correctly installed when you installed Office, and you should skip the following installation steps. However, if the words Data Analysis are not at the top right of your monitor screen, then the tool pack was not installed when you installed Office onto your computer. If this happens, you need to follow these steps. Click on File menu. Select Options. Choose Excel Options. Creates a dialog box. Then click on Add-ins. Manage Excel Add-ins at the bottom of the dialog box. Go Highlight Analysis Tool Pack in the Add-ins dialog box. Then click OK. Now that you have installed Tool Pack, you are ready to find the regression equation summarizing the relationship between the number of shelf facings of Kellogg's Corn Flakes and the sales in your dataset. Remember that you need to remember that shelf facings is the X data, the predictor, and the sales is the Y data, the criterion. You need to click on Data at the top of screen. Click on Data Analysis. It is located far right at top of screen. Scroll down the dialog box choosing the down arrow and highlight Regression. Click OK. Input Y range, Sales, which is the range from cell B3 to cell B12. Input X range, Facings, which is the value range from cell C3 to cell C12. Click on the button to the left of output range to select this, and enter A44 in the box as the place on your spreadsheet to insert the regression analysis in cell A44. Click on OK. The summary output should now be in cells A44, I61. To find the regression equation for the straight line that can be used to predict weekly sales from the number of facings, we only need two numbers in the summary output in cell B60 and cell B61. The format for the regression line is y equals a plus bx, where a is the y-intercept, minus 0.65 in our example in cell B60, and b is the slope of the line, plus 1.54 in our example in cell B61. Therefore, the equation for the best fitting regression line for our example is y equals a plus bx, y equals 0:65 plus 1.54x. Observe the number in yellow color in cell B60 and cell B61. As you have seen here, predicting outcomes from the estimated parameters in regression only requires a few easy steps in Excel. I hope you like this course. Adieu.